for a tangent?
No.
Oh, just because it's long?
Find dy dx, and we think that
We got the same answer, but it's wrong.
But
I got the answer and wrong, it's okay.
But because he has answer matches
no,
yours?
because
Yeah.
both of us.
Yeah.
question 2M.
Yeah.
About the right answer.
Okay, so what did you do then?
Let's have a look.
I did 2 times.
Read the question out, read it out.
9x squared minus 144x
9x squared minus 144x.
plus y squared.
Yeah,
Here plus 7y squared.
hang on. 9x squared minus 144x plus,
7y squared.
yeah,
Minus 70y plus 744 equals 0 as minus 2, we say.
minus 2 minus 8. We'll put that in a moment. So this will be 18x minus 144 plus 14y dy dx minus 70 dy dx equals 0. So dy dx equals 144 minus 18x all over 14y minus 70.
Yeah, we got
Now what did you say the x was?
Minus 2.
minus 2 and minus
Minus 90 over 91.
So, okay, that's not what it says here.
It's, you are reading the answer of question 3M. I was doing the same. Question 2M is minus 90 over 91. I was adding the same mistake.
Okay, at least we're good.
At least I did
At least
it
we're
right.
good. At least we did it. Okay.
You got it, you got it. Okay, let's have a look at the next lesson now. We're looking at mappings and functions. Domain and range, huh?
Yeah.
Okay, so we're starting a new chapter. Mappings and functions, is it?
Yeah.
Okay. Yeah, so actually the first lesson isn't too technical. Yeah, so we'll just give some basic terminology. It gets a bit more technical in the next lesson, but we'll keep it simple for the moment. So we would have studied something like this, fx equals x squared, but we haven't really talked about the vocabulary. So this is called a function. And what this function does, this f function, it takes x, and what do you get back? You get back x squared, yeah. So that's what we mean by a function. It takes an x that goes in, and it gives you an x squared that comes out.
Goes with.
Like for example, f of 1, so 1 goes in and 1 comes out. F of 2 goes in and what comes out? 4. F of 3 goes into the function and what comes out of the function? 9. Why do you look so confused?
So we just put the number we have
Yeah.
instead of the.
Yeah.
Okay.
Okay.
I was like, oh, why are you square?
It's an example just.
Yeah.
Okay, you get the idea of function? So for a function, it has an input and an output. So let's talk about some vocabulary. So this here is called the function. That's called the f part. The a is what's called the domain. So, for example, let me give you an example. Take this function, and the b is called the codomain. Take this function square root. Can you use any x in this function?
No.
No, you cannot use
Minus.
minus. So we say that this function takes a real number, yes, but only takes positive real numbers. So the domain is basically like what you can use for x. So domain is another way of saying what is allowed for x. So the simple definition, domain, the set of values of x that the function can take. So some examples, domain of root x, that's equal to all positive numbers. What about domain of 1 over x? That's all numbers except 0. What about the domain of x squared? Well, that's all numbers. Yeah. What about one more, domain of log x? No?
No minus.
And no 0. So all positive numbers except 0. Okay? So basically domain is what's legal, what's allowed by the function. That's all it is. Okay, so are you happy with what domain is?
Yeah.
Yep. So the next, there's only 2 definitions for this lesson. The next one is called range. So the range is the set, go on, have a guess, the set of values of, go on, what could it be? No, not x, we've just done x.
Set of values that the function can give.
Yeah, so the set of values of y that the function can give. So domain, range, they go together. Domain, the x's, range, the y's. Makes sense? That's okay? Now, calculating the domain and the range can sometimes be very tricky. We'll do some simple examples and then more difficult ones. You're writing this down? Yes. You're writing this down as well? Maybe you can take the headphones off. It prevents the maths getting into your brain. It acts as a barrier. Yeah, okay, yeah. You got this. Okay. What's the range of x squared? Not quite. You don't get everything back from x squared.
Not positive.
Not 0?
No, you
All positive.
all positive. You only get positive numbers or 0 back from x squared. What about the range of ex? Positive numbers. What about the range of 1 over x? It's almost like or except 0. So everything except 0. So to get back. So just from a graph point of view, let's just take something like I don't know, some graph like this, a quadratic type of graph like that. This is x and this is y. So, oops, that's not the one. The range is the y's. So on this graph, everything here down, this is called the range. because it's the y values you can get. Does that make sense?
So why down?
Well, because there's no y's up here. This is the maximum height.
Oh,
So you can never get y's up here. And what would be the domain here? Well, technically the domain is all the real numbers, because this graph continues out left and right. So you can use any x. Your y's are only from here down though. So for example, maybe here the domain is all real numbers, and the range is everything less than, for example, let's just say 1 or whatever. Okay? That's okay? Yeah, so we got the basic idea here. So let's have a look at some examples. So, find the domain of each of the following. Questions from? Question? No. How about we'll do this one. We'll start off with, we'll do B, D, and H. So if you just write the question down and I'll do it. So B, D, H. Okay, tell me when you're ready. Yeah, you don't need much space, like maybe this much space. Okay, can I do B now? So, can you read out B? What is it? G or something?
Yeah.
So, okay, so function gx equals, what is it?
3x squared plus 5x plus 3.
Right. This one's a little bit of a trick. The domain is just OR. It's all real numbers. If you think about it, there's no x you can't use. You can put any x in here, right?
Yeah.
So that's it. For this one, that's it. It's all real numbers. Everything is allowed. Now it gets a bit, that was the first one. It's easy. So what's the next one?
DHX equals 1 over 8x minus 16.
Okay, so think about this. You can use all numbers except the number that makes the bottom 0. So we can use all numbers except, and yeah, 8x minus 16, we don't want that to be 0. So we don't want x to be 2. So the domain is all the real numbers except 2. That's the domain here. Again, I hope that makes sense. Okay, and what's the next one now?
Hx equals square root x squared minus 20x plus 1.
Right. So, here, if you want the domain, you can only use x's that make the inside of the root a positive. These are the only allowed x's. So that means we have x minus 25, no, the calculator will destroy our brains. X minus 25. Alright, fine, you tempted me too much.
Alright, that's right.
Only 10.
Only 10? Okay, of course, 10 and 10. X minus 10, x minus 10, greater than or equal to 0. So if you draw the, I don't know which way you did it with Roland, but the way I do it is we mark off the 10s here. 10, we draw the quadratic. Is this how you did it with Roland?
Yeah.
And the good news is, we can actually use everything, because everywhere the quadratic is above. So, in fact, this one here, the domain is actually all real numbers. That the good news is that this quadratic stays positive. If it didn't, we would only use, for example, if it turned out to be something like this. Who we got? Yes.
Can I know you for 2 minutes?
Just me or them?
Just you.
Okay. Guys, why don't you just try K? Try K. Go.
Graph.
You make a graph and
You don't have.
You don't have to. All you have to know is the two numbers, and you know it's a happy quadratic
If here you
How do you know that
stop
it's
in
happy
x,
because x squared is positive. That's going on.
What?
X squared.
yeah.
Yeah.
this is an express plane. You can stop in x bigger than 10. Yeah?
So okay, so it's x squared. It's not minus x squared.
Yeah.
So it's a u. So it's not going down.
Yeah.
And then you know the two numbers by factor. Right?
Yeah.
If they're not negative, then that's everything that's up.
Yeah.
And if you want it to be bigger than 0.
Yeah.
Okay, so I factorize this. And
X
It's
plus
6 and minus 2.
X minus 2, X plus 4, X plus 1.
I think I only care about the denominator
Because
because
only z equals 0,
then the whole thing would be wrong. Denominator is out.
This is
This and x minus 1. So x equals 4. Here for x. You will bracket it.
So it's
X equals 4, x equals 1. X
6x minus 6x plus 2.
Huh? What?
The factors. X minus 6x plus 2. And then it's x minus 1, x minus 1.
no.
Are you doing k?
Yeah.
X squared minus 5x plus 4. That's x. That's 4 and 1.
Minus 4 and minus.
Yeah, that's the
Yeah.
factors, but x equals 4
Yeah,
and 1.
yeah.
Yeah.
So, and it's a happy quadratic. 4 and 1 is like this, period.
Yeah.
It's all up.
Yeah.
And you know it's happy quadratic because this is positive.
Yeah.
That's it.
Done. So you won't go for the denominator.
You only go for the denominator because this would only make sense if this doesn't equal
Yeah, if
0.
it's 0, then it won't be.
Alright.
Yeah,
If
yeah.
this can be 0, it's okay, but this can't be. The denominator cannot be 0. Denominator can be, it's fine.
So the denominator should be always bigger than 6 and 1 and 4.
Yeah, it's not all the positive numbers. It's all except 1 and 4.
Well,
Because you don't want the bottom to equal 0.
Wait, okay, wait. So
And when you solve 1, it become 1 minus 4, 1 is 4, and it's 5 minus 5 is 0. And we don't want it to.
yeah, so it's except 1 and 4.
Yeah.
Yeah, that's what we got. It's 1 and 4.
Not except or
Except 1 and 4.
No, not except.
Every number except, every real number except 1 and 1.
Same she's
Yeah, that's
trying
what
to
you're
say.
saying. Is that what you're saying? Every real number except 1 and 4. Yeah.
Ah,
Oh, except as in not 1 and 4. I don't mean
Oh.
except as in. Yeah, okay.
All of us y except
You're the.
for
Yeah. It's not A C C E B T E X C E B T.
No one watches.
I know what you will say.
Alright, how do we do with K here? Think you got it? Good stuff. Let's have a look here. Alright, can you just read it back to me? What is it?
x squared minus 4x minus 12
X squared minus 4x minus 12 over
x squared minus 5x plus 1.
So, that's x minus 5
4.
plus 1. Thank you, 4.
Minus 4.
X minus 4, X minus 1.
Yes, minus 4 minus 1.
Yeah.
Yes.
So what's the domain, do you reckon? All real numbers except 1 and 4. That's it. Except, you know this word? Yeah. Okay.
I know.
Now you know. Alright, okay. Except 1 and 4.
Isn't that ACCE?
No, that's yeah, it sounds the same, except. What's the difference here, guys?
Except
Big difference.
like everything
It's
but
but.
But not
Yeah.
like this. But except is agree.
okay.
Yes. Okay.
Except not a tick. That I can study.
Yeah. I accept that I'm a bad student. Yeah.
Regard.
Quotation mark.
I
Regard.
For your
Regard.
bad student.
Who should I quote here?
For your.
The one who is not here, Mahmoud and Andy.
No, we won't pick on them. We go anonymous. Okay. Now on to range.
What about M?
M.
Yeah, the question M.
Where is it?
This one here. It's a bit of a trick.
But it's C.
Yeah, but does anyone know the domain here?
What?
All numbers. You can put anything into sign. Test it. Like sign any number. It's fine. Yeah. Are you playing with your calculator to see if my story checks out, yeah? Yeah.
Next one.
What is this?
Okay. Guys, look up. Guys. The next one, the range, is quite difficult. It's not as easy as the domain, okay? So please watch carefully for the range. We can do the range as follows. These are the steps. Step 1, replace f, the function, replace the function with y, for example. Step 2, rewrite as equal to 0. And step 3, what y's make 2 solvable. Now that's very, I'll explain with an example, a simple example first. But these are the 3 steps.
I got an error with that.
With sign, you did not.
I got an error.
You did not. Impossible, because sign can take anything.
What?
Make what y's make 2 solvable.
Why?
I'll explain with an example. There's 3 steps.
Why F?
Y is like this is plural. You know, like dogs. It's a plural. Yeah. Adnan, stop playing with your calculator. Come on. Can I do an example now?
Yeah.
Right, we'll do a linear and then a quadratic and then a more difficult one. Okay? May I continue now?
Yeah.
Okay, so, go on, Mir?
Yeah.
Yeah, okay. So let's take this function for example. 2x plus 1. What's the domain? Domain, what's the domain? Any real number. And the range is also any real number, but I want to show you the method to get that answer, okay? So step 1 is replace this with y. That's step 1 done. Step 2, you make it as an equation equal to 0. So that's 2x plus y, 1 minus y equals 0. Or to be extra clear, that's 2x plus bracket 1 minus y equals 0. Now the reason I did that is to make it look a bit more like mx plus c for style. So step 2. And then finally, you need to ask yourself, what y's will make this solvable? Any y can be used. You know, because if you rewrite this as minus 1 minus y over 2, it doesn't matter what y you can use. You can say any y will be solvable. It will be solvable. So it doesn't matter what y you use. You know, if y was 1, 2, 3, it doesn't matter. This equation can always be solved. So this is a little bit of a silly example because it didn't really do anything. So we'll do one now that's a bit more realistic. Okay. Can I scroll down? Yeah. Another example? Alright, so let's have a look at this example. More realistic. Fx equals 1 over x minus 1, for example. Right, so what do I do first? I say y equals 1 over x minus 1. Next.
1 over x minus 1 minus y equals 0.
Yeah, so I write x minus 1, y equals 1. Right, bring that up. Then I have yx minus y minus 1 equals 0. Yeah? So then I have yx plus minus y minus 1 equals 0. Can I solve this for any value of y? No. There's one value of y that will make an equation not solvable. What is it? 0. Because if you think about this, this is like mx plus c. Yeah? This is always solvable except in one situation, and that's when the line is parallel to the x-axis. It won't cross the x-axis. In other words, if the y is 0, there is no x anymore. So how could I solve for x? So the idea is here, it's any y except 0. If y was 0, then you would have this equation. 0x minus 1 equals 0. Minus 1 equals 0. It doesn't make sense. So the answer here is all real numbers except 0. Yeah, it's getting a bit tricky now, but we should write this one down. You can do it. Be strong. I'm not strong. Maybe Iyad can do it. Yes? Alright. What? It didn't look like it was that tight, was it? You're tired? Yes, yes. Do you have breakfast?
Cereal.
Just cereal. We all know that's not enough for you. Alright, can we do another example?
Yes,
Yeah. Okay, so let's say we have a quadratic now. Y equals x squared plus 1. No, sorry, I mean fx equals x squared plus 1. Okay, first step, y equals x squared plus 1. Equals 0. So now next step is x squared plus 1 minus y equals 0. Or, to be very clear, 1x squared plus 0x plus 1 minus y equals 0.
Okay.
So what type of equation is this? Quadratic. Are quadratics always solvable?
No.
No. They require what?
there should be no,
The discriminant should be what? Do you use this or the with Roland?
No.
both,
Oh, okay. Discriminant should be,
not, minus and minus.
Bigger than
yeah, discriminant should be positive. That's the only way to make this solvable. Okay? So, discriminant is what? B squared
Minus 4.
4AC.
minus 4ac should be positive. Yeah. So that means 1 minus y should be negative. Why am I saying that?
Because you put the sign.
I divided by minus 4. So that means y should be bigger than 1.
Yeah.
And that's it. The range is all numbers bigger than 1. Actually, sorry, it could be equal to as well.
Yeah,
Yeah, because
one-
0 is fine, yeah.
Yeah.
So the range is this, all numbers from 1 to infinity.
Why did you write like this? Like 1 to infinity, why? This.
Did you not learn this in semester 1?
I
Oh, you
didn't
should.
understand this.
Oh, you don't understand it? Watch my video then. Yeah. This you need to know for the exam. Okay, so I want you to write this down, but just before we finish up, I want to show you this on the graph. So what I'm saying is, the domain should be all real numbers, and the range should be all numbers from 1 to infinity. So the y should only go as far down as 1. That this should be missing. We'll have a look at a graph now for this one.
The exact rule is not to fetch that.
Oh no.
Thank God.
Oh, dude.
Where is the graph?
What?
Where is the graph?
What do you mean, where's the graph? I'm waiting for the program to load. Right. Look, there you go, there's the graph. You see, guys? Range is from 1 to infinity. And the domain is everything. Okay. Now these questions, these ones are okay, but they get very difficult at K. Now for the exam, I've seen questions from A to L or to M. Yeah, basically A to M I've seen in the exam. Except for the only one I haven't seen yet is K. Now that doesn't mean, of course, you won't ever see it. I'm just saying I've not seen it yet. But the other examples from A to L I've seen in the exam, or something very similar to it. So when you're doing these, you should be able to do these ones. If you have trouble with K, that's fine. K is very difficult. In fact, I'll probably do this in the next class if you try it at home. But the other one should be okay. The method is the same for all of them. Okay. Usually what happens for these is that you make a quadratic and you can use the discriminant, or like in the last one, you make a linear and you don't want the slope to be 0, because then it doesn't have an answer. It's just parallel to the x-axis. So my little hint here is normally you end up with something like this: mx plus c equals 0, and you have to say, well, we don't want m to be 0. Or you can end up with ax squared plus bx plus c equals 0, and we want the discriminant to be positive. Yeah. This is very, very typical. Okay, so it's important you try these at home. Otherwise, you're just wasting your time. No, don't say that. I want to see work, not hear that you'll do work. Yeah?
Will I start with the bottom or all of them?
What do you mean?
When I say y equal, this is f of x, the very step
Yeah.
y equal.
Yeah, so like, yeah, like here you would say y equals all of this. And then what you do is you would take this,
to the y.
yeah, and then you take this to the y and then rearrange it to equal 0. Make a quadratic. Discriminant should be positive. This solution gives you the y's. Yeah. Miss Sharif, you're always so excited to leave my class. It's almost like you don't want to be here.
No.
Oh, okay, because that's how I feel. He thinks I'm crazy. Okay. We'll finish there, so.